I have 5 exam questions coming from the 2020 science paper 2, which is chemistry. So, of course, it's G12 internal, but it doesn't matter, division is division. The first question says, the diagram below shows a simplified periodic table. So this is a skeleton of a periodic table. That's saying the letters used are not symbols of the actual elements. Which element, A, B, C, or D, is the least metallic? Now, which one here is the least metallic? One thing that you need to know about metals, about the periodic table, is that as you go from left to right, metallic property does what? Decreases. It is as you go from left to right, metallic property decreases. And as you move from right to left, it does what? It increases. So since from left to right is decreasing, D is the least one. You see how easy it is, right? Question 7. Which property shows a decreasing trend in the elements from group 1 to 7 across the periodic table? Let us read the question again. Which property shows a decreasing trend in the elements from group 1 to 7? Number 1. Our main interest here is decreasing. Okay. Number 1. Non-metallic character. No. Non-metallic character that does not decrease as you move from group 1 to 7. It actually increases. The one that decreases is metallic character. So metallic is one that I was showing by these arrows, but non-metallic is the opposite. As you go from left to right, it increases for non-metallic, and vice versa. So this one is out. The number of electron shells. Well, the number of electron shells increase as you go this side. Why? Because shells the proton number keeps on increasing. So this one is also out. Radius of the atoms. Reactivity with what? Well, reactivity with water, all right, does not decrease. It actually increases. Now, what you need to know is about the radius of the atom. As you go from left to right, in as much as the number of shells increase, but the atomic radius decreases, all right, slowly by slowly, because the tendency to accept electrons increases. So those shells, they are very much closer as when you compare to a normal metal, that for example the one which is in group 1 or 2. So as you go from left to right, the atomic radius decreases because there's an increase now in the nuclear pull toward the nucleus. So those shells, they end up being closer together. So our answer here is what? C. Okay, we move on. Which one of the following elements burns in air to give a compound which dissolves in water to form a solution of pH 2? Now, they are not even interested in you knowing the actual element or the yes. What they want is pH of 2 is just acidic. Get the concept right? The pH of 2 is just acidic. So which compound here, when it burns in air, it will form an acidic compound or solution? Sulfur. Sulfur can form sulfur dioxide, right? It will form sulfur dioxide when it burns. And this sulfur dioxide, when put in air, in water, it will form either sulfurous acid or sulfuric acid. But this is acidic. Question 9. Identify the ion, all right, which will give only a clear solution when treated with excess of aqueous ammonia. Now, you need to know about qualitative analysis. If you are not okay with qualitative analysis, you need to get that chart for qualitative analysis. You can even download it on Google. Just go and type qualitative analysis for ions. They will bring for you. Alright, nevertheless, usually a clear solution with ammonia is usually what? Zinc. I know it personally, so yeah. There's not much to explain. You just need to master that same chart. A learner titrates aqueous sodium hydroxide from a purette with the dilute hydrochloric acid in a flask. After the titration, the flask is emptied. What is the correct procedure before the next titration? Imagine you are carrying out a titration, all right? Then you empty the flask, right? Remember that you've got a burette and a flask where the reaction takes place. So they are saying before you do the next step, what are you supposed to do? All right. A. Rinse out the conical flask with a dilute hydrochloric acid. You don't have to wash, all right, a flask with a chemical like an acid or a base. You don't do that. So A is completely out. B. Rinse out the conical flask with aqueous sodium hydroxide. I'm just from saying you don't do that with bases or acids because sodium hydroxide is a base, or to be specific, is an alkaline solution. Okay. C. Rinse out the conical flask with distilled water. D. Use the conical flask again without rinsing. So you can't use it without rinsing, but you can use it for the next step when you clean it with water. Now, distilled water is needed. Don't just, well, you can use any water, but they recommend distilled water because it is of a certain purity and certain degree of criteria. You get the concept, right? Even the pH of it is that can allow for you to clean the utensil nicely. So our answer here is C. It's quite simple, and I hope that you enjoyed the video. Follow for more.